Mokaku has revealed that the James Webb Space Telescope has produced a groundbreaking discovery, one that reaches further than ever before, beyond the observable universe. This extraordinary telescope is shedding light at the very edge of space, allowing us to enter a vast expanse filled with galaxies, stars, and fascinating mysteries that make us reflect on past cosmic events. Long ago, ancient stories spoke of the beginnings of the universe, tales of early galaxies and cosmic birth. Join us on an exciting journey to the farthest limits of the observable universe as we uncover the secrets of the ultimate space horizon. If you're a fan of the latest updates about the universe and its wonders, subscribe to our channel, hit the like button, and share this video to help it reach a broader audience. Don't forget to activate the notification bell. The James Webb Space Telescope, JWST, has achieved a remarkable feat by identifying galaxies that existed just 500 million years after the Big Bang, a truly amazing accomplishment. Now, we are invited to partake in this cosmic revelation as JWST rewrites the story of the universe, revealing marvels beyond our imagination. The observable universe, the boundary between space and time, has long been the focus of humanity's quest to understand our origins. Curiosity has always driven us to explore the cosmos, seeking answers about the nature of existence itself. Even ancient civilizations, without advanced technology, looked to the skies and crafted remarkable myths about celestial beings. Using rudimentary tools, they observed the heavens, mesmerized by the lights and patterns above, and considered possible connections between Earth and the cosmos. Scientists like Galileo Galilei had a profound impact on our understanding of the universe. His observations of Jupiter's moons demonstrated that celestial bodies could orbit objects other than Earth, a revolutionary idea that contradicted the geocentric model. This discovery helped usher in a new era of astronomy. As technology advanced, telescopes like the Hubble Space Telescope scanned the skies, capturing stunning images of distant galaxies. Its lenses revealed how stars form, how galaxies collide, and how black holes function, fueling our curiosity and deepening our cosmic inquiry. New mysteries emerged. Dark matter, dark energy, and background radiation gave us glimpses into the aftershocks of the Big Bang. Today, the James Webb Space Telescope, an intrepid explorer of cosmic knowledge, continues this legacy, revealing the hidden universe through infrared observations. Leading physicist and futurist Michio Kaku plays a crucial role in this quest. He inspires us with an insatiable curiosity to explore visible space. According to scientists, the observable universe spans a little over 93 billion light-years, a vast region filled with galaxies and celestial wonders. However, an intriguing question arises. If the universe is estimated to be only 13.8 billion years old, how can it stretch across 93 billion light-years? This profound mystery challenges our understanding and leads us to consider the universe's expansion. Think of it like a loaf of rising bread in the oven. The galaxies are like raisins in the dough. As the loaf expands, the raisins move farther apart. Since the Big Bang, this expansion has continued. Galaxies are moving away from one another, some so distant that their light has not yet reached us. It's like trying to chase a train that has already left the station. This boundary, known as the particle horizon, marks the edge of the universe we can observe. What's even more fascinating is that the universe's expansion isn't slowing down, it's accelerating, driven by an unknown force called dark energy. Some galaxies may eventually be pushed so far that they move beyond our observable universe. Beyond this point lies the unknown, territory hidden from view. Using data collected by the James Webb Space Telescope, scientists have discovered that galaxies formed between 500 and 700 million years after the Big Bang. To understand this, remember that the universe is 13.8 billion years old. The light from these ancient galaxies gives us entirely new insights into the early cosmos. By examining this ancient light, scientists can estimate when these galaxies first emerged. Thanks to JWST's remarkable capabilities, galaxies from the distant past, far beyond what we could previously observe, have now been detected. The infrared capabilities of JWST allow us to peer into the very beginnings of the universe. These discoveries prompt a fundamental reassessment of our understanding of cosmic evolution. By studying the light emitted by these early galaxies, scientists can now analyze their composition, structure, and the conditions under which they formed. Mokaku has disclosed that JWST captured images of galaxies that appear more advanced and distant than previously imagined. This unexpected discovery raises questions that may challenge current astrophysical theories, pushing the boundaries of knowledge. Kaku even suggests a fascinating possibility, that some of these structures may not be galaxies at all, but rather large black holes formed at the birth of the universe. This speculative idea could lead to revolutionary breakthroughs in physics, testing the very limits of our current understanding. He also envisions a future where seismic refractions caused by earthquakes could be predicted using artificial intelligence and supercomputers, potentially saving lives and changing how we interact with our planet. Michio Kaku's reflections remind us that the boundaries of our understanding are ever expanding. The universe is far more intricate and enigmatic than we've ever considered. The mystery of what lies ahead, beyond what can be seen, continues to captivate us. Kaku offers a thought-provoking perspective, challenging our assumptions about the limits of space. He argues that our current limitations stem from our ever-developing technologies and perceptions. According to him, the notion of a final boundary to the visible universe is not absolute. The seeds of space exploration were sown centuries ago by early stargazers. Today, we continue to move forward with ever-advancing technology. As science progresses, more cosmic secrets will be uncovered. Let us know your thoughts in the comments. If you enjoyed this video, make sure to click the like button, subscribe to our channel if you haven't already, and share this video to help it reach a wider audience. Thank you for watching, and we'll see you in the next episode, as we continue to explore new technologies and the vastness of the universe. Each new discovery made by the James Webb Space Telescope expands our reach, pushes boundaries, and challenges everything we thought we knew about the universe and its origins. The universe's mysteries are deep and ever-expanding. As the James Webb Space Telescope, JWST, continues its mission, the implications of its findings ripple across multiple scientific disciplines. Not only are we witnessing the formation of galaxies in the infancy of the universe, but we are also beginning to question long-held assumptions about the timeline of cosmic development. One of the most groundbreaking revelations from JWST is the discovery of highly evolved galaxies in a time when the universe was still in its early stages, raising fundamental questions. How did these galaxies form so quickly? Could our models of galaxy evolution be missing something crucial? Or are we on the cusp of discovering new physics that will reshape our understanding of how matter organizes itself in the cosmos? These ancient light signals, traveling across billions of years, bring with them stories frozen in time. Through them, we are not only learning about distant galaxies, but we are also gaining insight into the conditions of the early universe, such as temperature, density, and chemical composition. Each image, each spectrum collected by JWST, is like a page from a cosmic history book, one that until recently, we didn't know existed. As we stare deeper into the abyss of space, we also confront philosophical questions. What is our place in the universe? Are we alone? Or is life, like stardust, scattered throughout the galaxies, waiting to be discovered? These questions drive both scientists and dreamers. Visionaries like Michio Kaku remind us that our journey has just begun. He often emphasizes that technological advancement is exponential, and what seems impossible today may become routine tomorrow. Just as the telescope has expanded our vision, quantum computing, artificial intelligence, and next-generation propulsion systems may one day allow us to not only observe but explore these distant frontiers. The next phase of cosmic exploration will likely involve collaborative missions, integrating JWST data with new observatories such as the Nancy Grace Roman Space Telescope, the European Extremely Large Telescope, and space-based gravitational wave detectors like LISA. These instruments will provide complementary views of the universe, offering insights into the nature of dark energy, exoplanets, and even the first black holes. But perhaps the most profound takeaway is this: the more we learn, the more we realize how little we truly understand. The universe continues to hum with mysteries, and each discovery reveals new layers of complexity. We are not merely observers of the cosmos, we are participants in its unfolding story. As we continue to unlock the secrets written in the stars, we are also uncovering something fundamental about ourselves, our origins, our destiny, and our unyielding curiosity. So stay with us as we journey even deeper into the universe. Subscribe, share, and be part of this cosmic conversation. Because what we find next may forever change the way we see the stars, and ourselves. Kaku continues to challenge our perceptions as we stand at the leading edge of an exciting age of discovery. The universe may be vast, but our potential to understand it is equally limitless. The questions we ask and the discoveries we make today will be shaped by tomorrow. With each new observation, we come closer to answering the most profound questions that mankind has ever posed. From the early days of stargazing to today's advanced telescopic imaging, humanity has come a long way in its quest to understand the cosmos. However, we're only scratching the surface. The more we learn, the more we realize how much there is yet to uncover. The James Webb Space Telescope will undoubtedly play a significant role in shaping the future of what we know about the universe, but it's just one of many tools that will lead us into unexplored territory. As we look to the future, we must keep in mind that the universe is an ever-changing, dynamic place. What we know today may be completely different from what we'll understand in the coming years, thanks to advances in technology and our growing curiosity. Whether it's through studying the cosmic microwave background radiation or analyzing distant galaxies, we are entering a new age of space exploration, one where the unknown is as thrilling as the established. Our journey of discovery will take us to locations that challenge the limits of our imagination and push the boundaries of science. Michio Kaku's insights serve as a reminder that the future of space exploration is not just about understanding the cosmos, it's about unlocking secrets that have been hidden for billions of years, secrets that could alter our lives forever. The mystery of the universe beckons, and as we continue to explore its vast depths, we'll continue to ask the big questions. What lies beyond the observable universe? What forces are driving the expansion of the cosmos? How do these discoveries change our place in the grand scheme of things? These questions inspire a sense of wonder and excitement that fuels the passion for exploration. With each new discovery, we come closer to responding to them, and possibly uncovering answers to questions we haven't even thought to ask yet. Let us continue to be inspired by the universe and its infinite possibilities. The future is full of promise, and as we push the boundaries of our understanding, we'll learn more about the cosmos and about ourselves. Join us on this journey. Let's explore together as we solve the mysteries of the universe and venture farther than we ever have before. The James Webb Space Telescope has already provided us with glimpses into the earliest days of the universe, but the discoveries are only just beginning. The mysteries of space are not confined to the stars. We can see galaxies that extend into realms of dark matter, dark energy, and the forces that govern the very fabric of space and time. These invisible elements may hold the key to comprehending the nature of the universe, and the answers we seek could be much more complex than we ever imagined. One of the most intriguing aspects of space exploration is how each new discovery leads to more questions. The more we learn about distant galaxies and the expansion of the universe, the more we realize how much is still unknown. This journey of discovery is a never-ending cycle. Every advancement brings us one step closer to the truth while simultaneously uncovering new mysteries to solve. As we study galaxies from the early universe, we find that our understanding of cosmic evolution is far from complete. There is still so much to learn: how galaxies formed, how stars are born and die, and what happens when black holes collide. The work of Michio Kaku encourages us to look beyond traditional boundaries of science and to consider daring new possibilities. He suggests that some findings from the James Webb Space Telescope might rewrite our understanding of fundamental concepts in astrophysics and physics. For instance, the possibility of discovering black holes masquerading as galaxies could force us to rethink our classifications and understand these massive objects in new ways. It's a thought-provoking idea that could reshape cosmology and open new avenues of exploration in physics. But Kaku's reflections aren't limited to distant galaxies. He also considers how advances in space exploration could have practical applications here on Earth. By using seismic waves generated by earthquakes, for example, scientists could capture data that helps predict future seismic events, potentially saving countless lives. The application of such technology could reshape our society and our relationship with the planet. As we learn to harness the power of data and artificial intelligence to predict natural disasters and understand Earth's dynamic systems, we will continue to refine our methods of exploring the universe. The James Webb Space Telescope is just one of many advancements in this journey. Future space telescopes and scientific instruments will allow us to peer even deeper into the universe, maybe even revealing portions that remain unnoticed by our current view. The next great challenge will be to answer the questions currently beyond our reach. What happened during the first moments after the Big Bang? What is dark matter, and how does it influence galaxy formation? What role does dark energy play in the expansion of the universe? These inquiries are at the forefront of contemporary physics and astrophysics. As we continue our exploration of space, we may find that the answers lie in the places we least expect. The mysteries of the universe are not just academic. They hold the potential to change our understanding of reality itself. By continuing to push the boundaries of what we know, we may unlock the ultimate secrets of the cosmos, answers that could change everything from our understanding of physics to the nature of existence. As humanity peers deeper into the fabric of the universe, we begin to realize that our quest is not solely about charting distant stars or uncovering the architecture of galaxies. It is, at its core, a journey inward, toward understanding our place in the cosmos, our origins, and our potential. Breakthroughs in quantum mechanics, gravitational wave detection, and multidimensional theories are starting to blur the lines between science fiction and scientific reality. Concepts like wormholes, time dilation, and multiverse, once confined to the pages of imaginative literature, are now being rigorously examined in laboratories and observatories across the globe. Michio Kaku and other visionaries continue to challenge us to think beyond conventional limits. Could there be other universes just beyond the veil of our perception? Is it possible that intelligent life elsewhere has already reached levels of advancement that dwarf our own? These are not idle questions. They are the frontier of modern science, and they demand bold thinking. As we expand our observational capabilities, including space-based interferometry and deep space probes, we may find evidence that shifts the foundational assumptions of our civilization. Discovering even microbial life beyond Earth would represent one of the most transformative moments in human history. But what if we uncover signs of intelligence, of civilizations that have solved the energy equations we only dream of mastering? These questions bring with them philosophical and ethical challenges, too. As we uncover more of the universe's secrets, we must ask, how do we handle this knowledge? How do we ensure that our progress benefits all of humanity, and not just a privileged few? The answers we seek must be accompanied by wisdom, humility, and a deep sense of responsibility. At the same time, Earth itself remains a cosmic miracle, a blue oasis teeming with life in a vast, mostly empty void. As we study the stars, we must also preserve our home planet. Our ability to understand space is deeply connected to our ability to care for Earth. The technologies we develop for exploration, renewable energy systems, closed-loop life support, AI-driven climate models, can also be used to protect our environment and foster global cooperation. In the end, the cosmos is not just something we look at, it's something we are part of. The atoms in our bodies were forged in the hearts of stars. The patterns of the universe echo in the structure of our DNA, in the rhythms of our minds, in the quiet awe we feel when we gaze at a starlit sky. Our voyage has only just begun. There are mysteries waiting in the silence of interstellar space, on the dark side of distant moons, in the uncharted gravity wells of black holes, and in the quantum foam that underlies all existence. Let us embrace this journey, with courage, imagination, and an unshakable belief in what we can achieve. The universe is vast, yes, but so too is the human spirit.